And now I think it's time for Tekla Structures. I will show you an example. So it's a live example of our tool to read automatically the road alignment. So the first thing I need to show you here is I bring the land XML file from the, in this case was NovaPoint, our road design software, and we have here the bridge. Okay? So I want to do the deck here. And this is real life. They didn't give us space here to avoid the change of super elevation. So we're going to start our deck, and for sure, maybe here in the middle is constant for 10 meters only, but then it's going to start changing again. So let's model the deck there. We use our new extension that is called Bridge Creator, and what this extension is going to do is we're going to read the road alignment. That is that land XML file. So we are not reading the reference, we're reading the proper file. Let me load something first. Look at this one. So we read the file, and then we need to say, this is our main line here, and then other lines. And this is a good example of the real, I wanted to keep as real as possible. Our colleagues from roads are not going to do the work for us. We ask for the road alignment and they dump everything they can and don't bother again, right? So they're going to give us a file full of lines that we don't need. So we need to pick the correct lines, but we don't know because we are not road designers. So we can preview that line by clicking there, preview, and then we can see here, that line is our center line, and then the other lines I need to define my deck are here. If I pick this one, I don't know where the line is at all. So after we do that work, okay, we understand their language, and next time we know that they use this in Norway, minus 2.1, minus 1.1, which makes sense. We go to the left, and then 2.1, 2.4, 3.1 to the right. But anyway, if we don't know, we can use the preview. We put the project, so base point, because we don't want the bridge to be in real coordinates, we want the bridge to be in the project coordinates, as I said before. And now we need to define the key section. So for now, I'm going to keep just one key section, and I can add two typical sections are here just to help as a starting point. We can bring a section from Tekla Structures that this working version I think is not working. Let me just try. Oh, it's working today. We can bring one section that we have in Tekla, and honestly, it's waste of time because it's faster to create the key section with a tool than reusing the key section from Tekla, and then we need to give constraints to those points anyway. Okay? So in this case, I have here an example. Let me put 90 degrees skew there. We have there a preview. I need to give a name to the object. I define the chainage for a starting point, chainage for end point, and the interval for triangulation. So if it is in a curve, let's use 0.2, 0.15, which is good enough, accurate enough, because don't come to tell me that, oh, it's a girder, we need accuracy of 5 millimeters. No, you don't need that, because we just give a couple of levels to the guys anyway. So 0.2 accuracy is good enough. If we have a simple bridge, increase the interval maybe for 1 meter, because it will take more time to calculate the triangulation. But we are not sure where are we, so 364.5 is where we start. Let's just look into that. So we can see here the preview. Yeah, this is our section going there. If we want then construction lines, we tick this box and we'll have every meter we can choose construction lines for later reference if we need. I'm not going to do it today. I'm going to look into, I know now where to start, where to finish. I gave a skew of 90 degrees. and I'm going to look into the key section editor. In the key section editor, and sorry about the design of this deck, I need more files to do even complex bridges, but we have 4 types of points. Alignment proxy points are the road lines that it just gave us. And when we choose the central line and the other lines, now they are made available here, and we can use it. So we don't want here all those 20 or 30 lines that they make available. We want just the lines that are going then. We pass those lines through that button to the table, and now we have here the blue road line. So if now I jump to the outer face point, that is a concrete point, I go to point 0. And I'm saying my point 0 is type 1. The master of that point is a center line. Horizontal constraint 0. Vertical constraint minus 100. So now it doesn't matter where that point road line goes, up, down, left, right, my concrete is going to follow. If I jump to the point 2, you'll understand now the workflow. I'll say the same, but now the master is the 2.1, 0 horizontal constraint, minus 100 down. Now we can have a wobbly double curved deck because the concrete is going to triangulate doing that change. When we get to the end of the deck, maybe this point 2, the constraint is that still the road line makes sense, but point 3, we don't follow the road line alignment anymore. Now we give the constraint is the point 2, and we go 250 down. If I want to change that 150, we just change there. So from here, every single point there now is constrained to concrete points, or not. Let's check that one, because I was changing this yesterday, and probably I changed the 0.5 to be constrained 1.2 meters from the road alignment. Who knows? But could be from that point, I think it's point number 1. So I can go there and say, constrain the point number 1, maybe just minus 800. And now it's going to follow that concrete point minus 100. Let's put back this one, and let's see what's happening with the other point. I was just playing with it. It's there for some reason. This point here is a good example to show a different way. This point 6 is still type 1. We can add points as a parallel to the cross section. We can define by point pairs, define by rotation angles. The tool is under development. I had no time yet to find real examples to use all this way, but they are here, and the team that, and I'm part of the team, but when they define these, sooner or later, you guys are going to need all these ways of placing points. And then we have different type points. These 6, I want to change the 6. So we have the type 1 that follows the master with horizontal vertical constraint. Type 2 now follows 2 points. Type 3 follow 4 points. You have as many as you want to play with. Let me try this one. I want this point number 6 to be type 2, to follow 7, and to follow 5. Okay, now let's play with that. Minus 200 just to see. Okay, I know I'm now playing with the vertical constraint with that point, and that one is playing with that. So let's put 500 just to see. Minus 500. So now this point is 200 below that point and 500 to the left from that point. This is not what I want to do. Maybe this is better. Between 7 and 5, with 0 there, 0 here, and I wanted 50% between both. Because I know the deck is opening, I want that to be always in the middle of these 2 points. But let's put this minus 200 down. So now I'm constrained to do 2 points, always 50% of the mid of that distance, and then 200 below that line. Okay. So I think I messed up my geometry, but I really don't care.
It's like rule set.
Let's create.
It's like rule set.
Yes, and we have one challenge. I'll go one key section, and I'm going to show more examples with more key sections. But I need to create this deck. So let's just see what's going to happen. So now we have a very strange deck, but almost impossible to model. Okay, it's just one section, but almost impossible to model in traditional way because of the top of the deck. So let's just copy this section, and then let's say at the 374 chain edge, let's edit and say that point number 6 now goes down. Let's exaggerate, goes down in the mid span. And now I need to copy that again for the end of the deck. So copy, and will be the 385, for instance. 385. And I know it's the same. So we're going to start when depth goes down and up. So select the object, create, and now it's going to replace the object with the new key sections. Oh yeah. Now you have a even more complex, but you know your distances. So we cannot deal with the parabolas, but if you get the dimensions, you can add, and you saw how easy it is to create a section based on the previous one, give the new value, and then you have all your deck along. But this is not enough. Let's model now something else. Let's see what this is B. B is the abutment. And if we analyze the abutment, it is the same thing. I know that this part of the abutment is parallel to the deck. That means it follows the road alignment 3.1. So if I pick that point, I guess that follows the road alignment. And it goes 200 to the right, 450 down. So when I create that, it's in the wrong chainage because I'm playing so much with these demos. So I need to put this into the correct chainage. So I need to analyze the previous one that starts on 364.5. I think we go down that way. I'll try 364.5. That's just 1 meter, just to see what's happening. I'm not very worried about that, honestly. Hey, right first time. But because I changed my deck, now I need to go to my key section and just adapt that. So you can see that after we create a couple of bridges, we can reuse the XML files that are saved under the attributes folder. We can reuse and adapt to the new alignment, to the new chainage, the new skew. But this is the most important. It's in curve and it's parallel to our deck. So now we need the back of the abutment and the cope. Before that, sorry. If I go to B, I can show a different type point here, edit. So the voids, so the radius is not working in this version, so I created 2 examples by creating voids, so openings. The difference between the inner face points and the outer face points is that we can have as many voids as we want, and for the outline you can have only one object, makes sense. So here I have interface B, they call it interface B and interface A, that is one group of points there for the opening, one group of points there for the opening. So now I can load the other one, that is going to be in a wrong change again, but doesn't matter, it's just for you to see that it's a simple object. For us to model this, we need to be very careful here because the top of the back of the abutment needs to follow that parallel line. And then the wing walls there, so C I have two key sections. So we start, let's see if I can preview that. Is a change, so 3, 5, 7 to preview the guides here. You see, one section starts larger and then goes to a small wing wall. So let me just create. And now we have a curved wing wall here at the back of the abutment. For the copes, maybe F, let's see, yeah. For the cope, now it's very, because the only thing I want you to retain for now is the workflow. In the workflow now you understand. The cope is going to follow again the road alignment. Then it goes up, down, left and right, and we have our constraints. But I was challenged then to do the drip underneath the cope, which is only probably 20 mil. Let's see, where is the point? 20 mil there. I created, so let me create this one and I'll show in the model. So, create. It's taking more time because you can understand it's so small, 20 mil to do the drip underneath the cope. That's taking a little bit more time to do the triangulation. Probably. No. Oh, it's here. Yeah. And now, look at that. We don't need more precision than the precision that we are offering. It's there. It's there. And it will be a nightmare to place. It's easy to place a rebar here, but it will be a nightmare for any contractor to paint these bars because they're going to be all different bars, all the way. And this has a spacing, now too much because I played so much with this model. This has a spacing constraint, 25 mil there, and here now is too much. I need to put this down, but could be precast, but could be a second pour. So we just put 0 constraint there, top and side, and then we'll have the edge beam as in situ second pour. So this is one example. If I load another road, and this one you can see, just with the curve, the upper elevation is going to change. You have to be careful with one. So I have one. It's not updating that. I'm not very aware with that. I just want to check what is revision 2. So for this exercise, I wanted to show what about if the road alignment changes. So I built a deck based on this XML file that was not the normal one, and then I changed it to revision 2. So, but I will load revision 2. It's 100 meters long, and it's 3 key sections. Because after I do this one, I'll show you the precast scope. And to do the precast scope, what I did was give me 10 meters. From this change to that change, I want to go with 10 meters. And then 25 mil spacing. Next scope will be the previous change plus 25 mil and then 10 meters extra. Because the top of the deck is changing so much, and you see left and right curve, takes more time for the triangulation.
So idea behind all that is showing just your work will follow changes of
Yes.
road alliance.
Yes. Yeah.
This is the main idea. Bridge designer should not, anyway, bridge designer should dance according to the road designer.
Yes, but we know that. But it is normal because when they design the road, they do a quick estimation of for the headwind, and they always go through the very narrow spacing. But they are not bridge engineers, so then they thought, oh, the deck will be 800 mil depth. That's not enough. So we need 1 meter. So then they changed the road alignment. Then we need to change everything. So here, this one, and you see, this is for us is real because we have viaducts like that, and it's a nightmare to model, not anymore. And is the last object I show here. If I load one of the copes, maybe the number 10. Let's see which road alignment is going to read the first version. So you'll see the cope in the wrong position because the deck has been updated, and let's pretend I need to give a name. Code 10. Save. Create. Let's pretend that this could be a good example. So the cope was there, the deck was updated, and the cope will stay. Should be here. Oh, it's a wrong because I have another deck that is here. So I need to go and look for my cope there, but all the settings are there saved. So and this will not happen. But this one here, it will be 10 meters long. If you want to do it precast that way, which probably they don't. Okay. If this is not enough, or probably you are already thinking in possible ways to use these, what about if you do a portic and again follows the road alignment, create, it will be much faster, the creation. It's here already in the preview section. And follows the road alignment. We give the constraint, whatever that constraint is, all the other stuff. Do we need that? Maybe. Sometimes we don't, but in this case, probably. And then the skew. Because I had 100, for the example, 100 degrees skew. But could be a different thing. Could be a wall. Let's see what's going to happen. Where is the wall? It's going to be there. Okay, so on top of that, let's delete this. It can be a retaining wall. We have a highway with kilometers of retaining walls. So we have the road alignment. The only thing here we need to ask from our colleagues is give us the line here behind the wall with the final ground level. And then it will be automatic because we give the constraint, let's say 100 mil up from that final ground level line, and we have our wall just in a couple of minutes. This one I'm not going to load, but you can do then normal. You see here, normal. The examples I have, it's a bit tricky to have this kind of two beams because the road is opening so much. And then you can have radius. And this is another wall, I'm not sure why, but okay, I need to close that. Yeah, the second wall then now, it's here and I change some constraints and I end up with the second wall just based on the first one, change the change some constraints and that's it. So this is our new tool that I think is going to be a revolution the way we now deal with the road alignment. It's going to help us to model our deck. If you have a precast bridge, eventually you model the traditional way, you place the precast beams, but maybe the top of the deck changes. So then we need to do a mix between traditional way of modeling and this tool. There is not one way to do things. There are many ways to do things, and depends what's your job. What's your job? Do you have someone in house that took a couple of months to build, or many examples of bridges, typical bridges using grasshopper? Yeah, do it that way. You have something like that. This is a nice way. We have precast. You can model the traditional way. So there is not right and wrong. It's always better to share and ask around, okay, what is the best workflow for this specific job, because despite I've been taught, so first with the normal training and then 20 days or 19 days in Finland, everyone forgot to tell me about cloning drawings. I did, my first job was 8 underpasses, 6 weeks, 2 guys, and we delivered. And then after a couple of months, Tekla guy came to the office in Scotland, and I was showing off our first job, was great. They said, oh, that's great, I bet you used cloning drawings. Cloning drawings, what is that? Oh, don't tell me every wing wall, every drawing of the portic you created from scratch. I said, yes. So ask around, ask for support from these guys, because there is where we get that fear factor, that is the learning curve. The time we spend learning curve shouldn't be put down into losses, should be put down as investment, because sooner or later we get that money back many times over. Yeah, so I will. We still have time. If we still have time, I will show you that cloning because it's important. Very fast here. Right. So I go to Tekla, and then cloning is documentation. And then the cloning is one video here.
That's erection instruction also
Is this way. So for non-Tekla users, this is one of my approach slabs. And then for every approach slab, we were creating the drawing from scratch. I developed some settings, yes. Okay, right click and you'll see. Right click and we have some settings as a starting point, which is a good start, but all the rest was manual. And this is just approach slab. Now you can imagine the wing walls and the porting and all that. But this is a small video just showing that workflow. So we have the approach slab cast unit. I create a drawing. I'm not worried with the settings. And that is an intelligent drawing with no settings. Now I load my settings. And this is what I have as one-click drawing. A plan with the title, 2 sections, elevation, with the bars in the middle of the group. Now I place the bars in a way that we can easily read the drawing, and then I'm going to add some tags. I'm adding tags the traditional way. Believe it or not, we all are always learning, and I didn't know about that fancy way of automatically placing the tags when I created this video. So I place the tags the traditional way. It's still quite fast, and I keep doing that exercise. And now I'm going to add a note because I want to clone, and then just for you to see that even notes are cloned. So the frame is not there because I took it off, obviously, but in normal settings we'll have the frame with the client and all the information. Now, first thing is, I'm going to change using direct modification, the end of wheel shorter and the drawing updated, and we have temporary ref clouds telling us, hey, this changed. Do you want to put your ref cloud, put it or not? Now I'm going to copy, and this is what I missed. I'm changing even more the object, and instead of creating the object, I'm cloning the object. I don't work as fast as this video, huh? So this is a second drawing. This is the biggest advantage we have in Tekla when we are talking about being efficient and comparing with the market. Because we can invest some time to do the first abutment, second abutment, it's fast. We do some time to do the first pier, second pier, is a couple of minutes. The same way as you see here. So I deleted some objects there, created an even smaller one, and I cloned again. Then I go there and tweak and make sure. Don't always trust 100% into the software, and that's it. So it's a very fast video.
It's really fast.
It's really fast, but this is what I missed because despite I've been trained by those guys, maybe they thought that was so obvious that they didn't need to tell me. So they taught me all the settings, and I created all those settings, but someone forgot to tell me about this fantastic stuff. And for new Tekla, we have the partial cloning that is inside the drawing. We can say, for instance, you have put dimensions into your pier, one, and then you have a viaduct, and the piers, they go all the way. You put the dimensions there, then you say, select that, partial cloning, and add that type of dimension, because they are intelligent, to all the other piers along the viaduct. And everything is going to be placed automatically. So it's not only cloning one entire drawing, it's cloning part of the drawing. We have a drawing with 4 wing walls. Place all the dimensions, the levels, the title, all that. The first one, select the first one, partial cloning, select the other 3, and you have all the dimensions applied. So this is where we're going. In 50 years' time, maybe we are building without drawings. Not until then. So until then, what we need to do is to keep developing more and more in order for you guys not to spend so much time doing drawings because it's boring. That part of the process is very boring.